In this module, we are going to talk about Firewall User Authentication. These are some of the topics covered by this module. We'll be looking at describing and configuring some of the authentication mechanisms available on the FortiGate devices to authenticate users. This includes local, radius, and LDAP authentication. We will also learn about two-factor authentication and user disclaimers. Finally, we will take a look at how to monitor and test firewall user authentication. By the end of this module, you should be able to describe and understand the different firewall authentication methods. You should be able to configure, monitor, and test firewall user authentication on FortiGate devices. Authentication is the act of confirming the identity of a person or entity. If we want to apply different security policies and profiles depending on the user, the FortiGate must know who is sending each traffic stream. The process of identifying who is sending what relies on the use of different authentication methods. After a FortiGate device authenticates the user and knows who he or she is, it can then apply the security policies and profiles depending on the user group and traffic destination. Local authentication is the simplest but most limited of the authentication methods. All the user account information, including passwords, is stored locally on the FortiGate. When a user tries to access any network resource that requires authentication, the FortiGate will request the username and password. Users must type and send their credentials to the FortiGate. If the credentials are valid, the user is successfully authenticated and can access the network resource. Local authentication is not a scalable solution and does not work well in implementations with more than one FortiGate. Each time an account must be modified, created, or deleted, the administrator has to manually do it on all of the FortiGate devices. Also, users might be required to enter their credentials more than once if their traffic is crossing two or more devices where authentication is required. With remote server authentication, the account information is not stored locally on the FortiGate, but on a remote central server. The FortiGate first requests the credentials from the user, and the user must type the username and password. But now, the FortiGate forwards the credentials to the remote authentication server. The server authenticates the user and replies back to the FortiGate with the confirmation that the credentials are valid. Finally, the access is open and the user can reach the network resource. There are two ways of configuring remote authentication. One way is to create the users locally on the FortiGate device and configure the unit to validate their passwords against the remote authentication server. The second way is to configure the unit to validate both the username and password against the remote authentication server. User accounts do not need to be created locally. All the user account information is stored only on the remote authentication server. Another way of doing user authentication is called single sign-on. It refers to existing authentication events being leveraged for firewall authentication. It is a mechanism that allows users to enter their credentials on the network only once. After entering their credentials, they get access to the network resources without having to authenticate again. The FortiGate devices will transparently authenticate the users, meaning that they receive the leveraged authentication events to know which user is located at which IP address. All user traffic coming from an IP address will be transparently authenticated as belonging to the user located at that IP address. Single sign-on can be implemented using one of the following two methods. FSSO, which is a Fortinet proprietary communication framework for collecting and forwarding user login events to FortiGate devices, and RSSO, when radius accounting packets are sent to the FortiGate devices containing login and logoff events. The FortiGate devices support the following protocols for remote authentication: Radius, LDAP, and TACAC+. Additionally, as explained in the previous slide, FortiGate devices support single sign-on authentication either by using a directory service such as Windows Active Directory or eDirectory, or by using a Radius server. Users can be grouped. As we will see later, we can specify which security policies are going to be applied to each group. We can create 4 different types of user groups. Firewall user groups are the ones used for local and remote authentication. Guest user groups provide visitors with temporary access to specific network resources. The FortiGate can automatically generate a temporary account for them. FSSO and RSSO groups are used for single sign-on. We cover these 2 user group types in a different module. We can combine different group types on the same FortiGate device. For example, we can have local and remote user accounts for users in Paris, guest accounts for visitors, and FSSO accounts for users connected to an Active Directory domain. The logic of a firewall policy with authentication is slightly different than the logic used with a normal firewall policy. In order to match the policy, the FortiGate unit checks the IP information. Once inside the policy, the following logic is followed. First, are the user's login credentials valid? Next, does the user belong to any of the groups defined for that policy? Finally, user restrictions are determined by the services, schedule, and destination address. UTM security profiles are also applied. If the user does not belong to any of the allowed groups in that policy, the next policy will not be checked. The authentication is considered unsuccessful at this point, and the user will be denied access through the firewall. It is also important to know that not all the protocols can trigger an authentication challenge. A FortiGate device will not challenge a user to authenticate unless he or she is sending traffic through the protocols HTTP, HTTPS, Telnet, and FTP. This means that an authentication rule will not allow any other protocol until the user first tries to send traffic through one of these protocols successfully. One feature that can be enabled in a firewall policy is the disclaimer page. This can act as a warning for users to state your networking policies or procedures. The disclaimer page content is customizable. Just like with any end-user agreement, a user must accept the disclaimer before being able to proceed any further. This is particularly useful when setting up a deployment for a public network. The authentication timeout is an idle timeout. The FortiGate device considers a user idle if it does not see any packets coming from the user's source IP. When that inactivity timer expires, the user is de-authenticated from the FortiGate device. He or she will need to authenticate again to send more traffic across the FortiGate device. By default, the authentication timeout is set to 5 minutes and can be changed from the GUI under the Authentication Settings screen. It is important to clarify that the authentication timeout for SSL VPN users is controlled by a different setting. In the case of SSL VPN, it is called idle timeout and is part of the SSL VPN global setting. Two-factor authentication improves security by preventing attacks associated with the use of compromised static passwords. With two-factor authentication, users are required to use 2 independent ways of identification. In most of the two-factor implementations, people must use something that they know, such as a static password, and something that they have, such as a token or a PKI certificate. The FortiGate devices support both token-based and certificate-based authentication. In this module, we will talk about token-based authentication only. Certificate-based authentication is covered in our Digital Certificates module. The token provides what is called a one-time password, which is a code that is good only once and for a short time. So, it is already useless by the time it gets compromised. There are two types of algorithms used for generating one-time passwords: time-based and event-based. Fortinet uses time, so it is important to have the FortiGate system clock and the token clocks synchronized. The one-time password can be delivered to users by one of the following three methods. First, users can have either a physical FortiToken or a FortiToken mobile. Both generate a new one-time password every 60 seconds. FortiToken Mobile is an app available for iOS and Android. Second, the password can be sent by email to the user. Finally, the FortiGate device can deliver the password to the user via SMS. Let's explain how token-based authentication works. The token contains a seed, which is a randomly generated number that does not change in time. The token also knows the time from an internal accurate clock. Both two numbers go through an algorithm that generates a token. The token has a short life, usually measured in seconds, so it changes with time. The user sends his or her static password and the one-time password or code provided by the token. A validation server, which in our case is the FortiGate device, receives those credentials and validates the static password first. Then, it proceeds to validate the one-time password. The validation server knows the seed used by the token. Also, the validation server's system time is synchronized with the one on the token. Therefore, by using the same algorithm, it can generate the code one more time and compare it to the one received from the user. If the static password is valid and the one-time password matches, the user is successfully authenticated. Again, both the token and the validation server must have the same seed. Also, both system clocks must be synchronized. To use a FortiToken, we first need to register it on the FortiGate unit. If it is a hard or physical token, we must enter the serial number. If it is a FortiToken mobile, Fortinet will have sent you an activation code, which you must enter on the FortiGate device. It is important to mention that without a FortiAuthenticator, which is another Fortinet product, we cannot register the same FortiToken on more than one FortiGate device. This means that each token can be used on only one FortiGate unit. If we need to use the same tokens on multiple devices, we must have a FortiAuthenticator unit. In those cases, the tokens are registered with the FortiAuthenticator and not with any FortiGate device. We will move now to LDAP and Radius, which are two of the standard remote authentication protocols currently supported by the FortiGate device. Let's start briefly reviewing what LDAP is and how it works. LDAP is an application protocol for distributed directory information services. It can also be seen as a database which contains, among other information, user accounts. The structure of this database is similar to a tree that contains entries or objects in each branch. Each of these objects has a unique identifier, which is called the distinguished name, or DN. The objects also have attributes, and each attribute has a name and one or more values. All this structure is defined in what is called a directory schema. The hierarchy of the LDAP tree tends to match the hierarchy of the customer's organization. The root of the tree represents the organization itself and is defined as domain components, or DC. In this case, If the company's domain is example.com, the root of our LDAP tree would be dc equals example, comma, dc equals com. Additional levels might include C for country, OU for organizational unit, and O for organization. User accounts usually have element names such as UID or CN. Here's an example of how we build all this LDAP information. On the top, we have the root, which we mentioned is dc equals example, comma, dc equals com. The first branches define the country. We have one branch for user accounts in USA, another one for users in France, and the last one for users in Canada. Then, and in the case of France, we have two organizational units or OU, HR for Human Resources, and IT for the Information Technology Group. As previously mentioned, this hierarchy usually matches the hierarchy of the organization, with user accounts in different countries and organizational units. Below the IT group in France, we have three users with the attribute UID as the element name. Each user is an object with attributes. For example, this slide shows three attributes and their values for the user J. Smith: the attribute UID, the attribute email, and the attribute object class. Also, as mentioned, each user object has a unique ID, which is called a DN or distinguished name. The DN for the user J. Smith is UID equals J. Smith, comma, OU equals IT, comma, C equals France, comma, DC equals example, comma, DC equals com.